Okay, so today we're going to talk about hydrosphere and freshwater resources. The first thing that we talk about is water availability. What is the distribution of the Earth's water? Well, if we look at this graphic, the very top of it looks at all water on the planet. So 97% of all water on the planet is in the oceans, and only about 3% of it is in fresh water. So if we follow that graphic down, we then look at just the fresh water on Earth. Almost 80% of fresh water on Earth is locked up in the ice caps and glaciers. 20% of it is in groundwater, and then only 1% of it is accessible fresh water. If we look just at the fresh water, we look at 52% of it's in lakes and rivers. 1% is actually in rivers, 38% of it's in soil moisture, 8% is in water vapor, so clouds, and just the water vapor in the earth, and then 1% of it is in living organisms. So how does this translate for accessible use? What's available for people and animals to use? So when we do all the math down through the different types of water, we realize that only about 0.0003% is available for use. So what does that translate into gallons per person? Well, that's 7 million gallons of water per person. That's more water than you will ever use in your entire lifetime. But there are places in the planet that are actually in what we call a water shortage. So why is that? Well, there are different factors that prevent an endless supply of water. There's only so much on the planet. The water that's been here since the formation of Earth is the same water that will always be here. And it ends up going through a cycle, which you guys are familiar with, the hydrologic cycle or the water cycle. And water gets stuck in different locations. It gets stuck in precipitation or in glaciers and ice melt. It can also get stuck in things like oceans, and then also in groundwater. So there's not an endless supply of water. It's a renewable resource. As it goes through the hydrologic cycle, it ends up being refreshed and cleaned and reused over and over again. So surface water systems. The first thing we're going to talk about is a watershed. Well, a watershed is an area of land that drains into a lake or river, and it can also be called a drainage basin. Each watershed is a complex combination of water, soil, air, plants, animals, and other natural resources. And many factors can affect the functioning of a watershed, such as logging, farming, grazing of animals, buildings. All different things can affect the functioning. The watershed we live in is known as the Merrimack Valley watershed. So here's a map of our watershed, and it starts all the way up in the North Country with the Pemigewasset River, and it comes down through Concord, Manchester, Nashua, and then goes through Lowell, Lawrence, Haverhill, Massachusetts, and eventually dumps out into the Atlantic Ocean. So watersheds are based on topography. All of this is going into a lower elevation. So rivers will always go from higher elevation to lower. The topography will affect the flow and the velocity of the water. Soil type is also important. And then buffer zones such as forests and wetlands affect the quality of water. How fresh or clean is that water in the watershed? When you're talking about watersheds, you're often talking about rivers, because water from your backyard little brook eventually will go into a bigger brook, which will eventually dump into a stream, which will eventually dump into a river. So that watershed all accumulates into the river and then will be transported down into the ocean. So rivers differ based upon their stage of development. The stage depends on the slope of the land that the river flows over, and they're classified as young, mature, or old. That doesn't depend on their age. It's actually just the characteristics that the river has, which again is based on the topography of the land. So we have 3 different river classifications. A young stream, which is here depicted on the left, typically flows swiftly through a steep valley. It's usually high in energy, often associated with white water rapids or waterfalls. Then you end up having a mature river. So this is less hilly, a little bit flatter of a topography. The flow is more smooth, and erosion is no longer concentrated just in the stream bed channel. The erosion occurs along the sides of the river, creating curves. The curves are caused due to changes in speed of the water throughout the width of the channel. This is where you have meanders forming. So meanders are these curves in the river. So that's a meander, and then it comes over here, and that's a meander. Old rivers usually flow even more smoothly over a broad, flat floodplain that has been deposited. When you're also talking about rivers, you often talk about pollution types, and there are 4 different types of pollution that affect the watershed. The first one is a point source pollution. Point source originates from a single identifiable source, such as a drainage pipe. For instance, if an industry is dumping into a river, such as a sewage treatment plant, we can say that is a point source pollution. We know where the pollution is coming from. It's coming from this point. Non-point source pollution is a little bit more harder to identify. It's caused by runoff from snow or rain that moves up over an area, picks up pollutants, and those pollutants are eventually deposited into a river or stream. Non-point source pollution would be an example of all of the salt that was on the roadways this winter. The rain is now starting to pick up the pollutants of the salt, and that will eventually end up in the groundwater, rivers, streams, lakes, and ponds. A third type of pollution has to do with eutrophication. Eutrophication is when nutrients, such as fertilizer, flow into a body of water faster than they flow out or are broken down. The fertilizer becomes filled with plant material, because remember, plants love fertilizer. So the plants grow because of the fertilizer. What happens is then the plants start to die, which happens every season, the plants die. Bacteria then begins to break down the plants. This causes a decrease in oxygen levels because bacteria use oxygen, give off carbon dioxide. So you have a decrease in oxygen levels with eutrophication. This then affects animals that live in the water, such as fish and shellfish and big fish. So these 3 different types of pollution are very important when we talk about the health of our watershed. Legislation helped to clean up our waterways using the Clean Water Act, which was passed in 1972. Before that, the waterways of New England, and actually the entire country, were very poor. My grandmother can often remember the Merrimack River, because she lived in Lowell, which is a big mill town, being different colors, depending on what type of fabric they were coloring that particular day. So the Merrimack River has become much cleaner over the past 40 years. So groundwater systems. Groundwater is water that soaks into the pores and cracks of rock under soil. And groundwater makes up 1/5 of all of Earth's fresh water, or about 20%. The amount of water held in groundwater systems depends on the permeability. How much water or pore space is there for the water to fill in? Groundwater continues to steep into the ground until it reaches an impermeable layer, causing the water to fill pore spaces above this layer. So groundwater systems have 5 factors. The first one is an aquifer. An aquifer is a porous, sponge-like layer of rock, silt, and gravel that holds water. Most of you probably are on a well system for water, so that means you're part of an aquifer. You drill down into the zone of saturation, and then you use a pump to bring up the water into your house. So that goes into this system here. You have a couple of different zones. You have the zone of aeration, also, or unsaturation, air, meaning there's air there. So there's zone of upper layer of the aquifer is filled with pretty much air and water. It's not saturated, it's unsaturated. Then you have the zone of saturation. It's the lower layer of the aquifer where all the spaces between soil and rocks are contained with all water. This level here between the two is known as the water table. It's the boundary between the saturated zone and the unsaturated zone. And when you drill a well, you want to be in the saturated zone. But if we have a drought, that water table is going to drop. If we have a flood or a lot of rain, that water table is going to rise. So depending on how much water is coming in through infiltration, will change our water table, either up or down. There's also areas of the earth that are aquifer recharge zones, typically your wetlands. So it's where water infiltrates the earth's surface and reaches the aquifer below. And there are 2 types of aquifers when we talk about them. An contained aquifer is, as it says, it's contained. There's a layer of rock or gravel that contains the water trapped between the upper and lower layer of less permeable clay. This is under a great deal of pressure. So a contained aquifer has a lot of pressure because the water is contained between 2 layers. An unconfined aquifer has just a less permeable layer on the bottom, no upper layer confining this aquifer. So there's less pressure on an unconfined aquifer. So when we talk about groundwater systems, we talk briefly about wells. Wells extend into the zone of saturation. So here's an example of a well. So you end up drilling down into a zone of saturation. Here's the water table in purple. And it pumps up water into your house. And the pump goes all the way down to the zone of saturation. If wells can go dry if that water table drops. So if this water table were to drop way down, that well would go dry. Pumping too quickly can also lead to sinkholes and collapse of the soil around it. Springs are a place where this water table here actually sits at the surface and the water actually flows out. It's a place where the water table meets a sloping surface. And then a geyser is a hot spring, so where magma is underneath the spring, causing it to erupt periodically. An example of a geyser would be Yellowstone National Park. Old Faithful is a geyser. So it's a spring where water meets the table, the water table meets the surface, but magma is actually causing the water to heat up and burst into the air. Now there are very common pollutants that we'll talk about in a little bit more detail in the next class, which affect the health of the watershed. So these are common pollutants that we talk about often. So things like mercury, arsenic, aluminum, nitrates and nitrites, which are fertilizers, so is ammonia and phosphates. And then we also have things like benzenes and PCVs and PCBs, are all common pollutants of water. We also, when we talk about water health, we look at common parameters, such as what's the pH of the water, how much oxygen's in the water, what's the turbidity or murkiness of the water, what's the temperature, is there E. coli in the water from birds. So all of these we'll talk a little bit more in detail in the next class. Now what I want you guys to do is go to your WSQ and fill in the summary sheet. Don't forget you need to come up with a question about this topic. I'll see you in class tomorrow. Have a good night. Tell me I didn't record.